Hello and welcome to Getting Started with Amazon Linux Workspaces. I'm Justin Stokes, and I'm a Senior Manager on our Productivity Apps Solutions Architecture team. Today, we're going to try and do a few things. We're going to give a basic overview of AWS's EUC offerings. We're going to talk a little bit about what is a workspace. We're going to talk about what are Amazon Linux Workspaces, and we're going to talk a little bit about how you set them up and how you scale. Now, Amazon offers virtual apps and desktop as a service via two products. Amazon Workspaces is our persistent desktop offering. It comes with three OS options: the Windows 10 desktop experience based on a server OS, the Amazon Linux 2 option, as well as a bring your own license option for customers that would like to bring their own Windows 10 media. You can access Amazon Workspaces via the Amazon Workspaces client using Microsoft Windows, Mac OS, Linux, Zero clients, iOS, Android, and Chrome. Our non-persistent offering is Amazon AppStream. It offers both a desktop and an application view. The application view can also offer a seamless application view using a Windows client. Outside of the Windows client, AppStream is available in your web browser using any HTML5 compliant browser. Amazon AppStream offers three OS options under the covers. It's Windows Server 2012 R2, Server 2016, and Server 2019. Both options are fully managed cloud services, so we worry about the underlying infrastructure and the scaling and security of the gateways. They both fall under the shared responsibility model, and instances are treated as though they are in your VPC. So connectivity to the VPC and from the VPC is in your account and something you should manage. Both options also allow delivery at scale. Workspaces and AppStream allow you to scale up and scale down as your demand requires. They're both highly reliable. Both of them are based on EC2 and are fully managed from our side and treated as a managed service. I highly suggest that you take a look at both offerings for your application and desktop needs. Now, let's get a little bit more into what are workspaces. Amazon Workspaces is our secure cloud desktop offering. It's a pay-as-you-go offering, so you pay strictly for what you need. Workspaces are allocated to individual users and can be used in both a monthly and hourly model. In the monthly model, there is a set price for each workspace based on the hardware specifics that you choose, as well as the operating system. In the hourly model, there is a much lower monthly fee to cover persistent storage, while there is a smaller hourly fee specific to running hours. So you pay for the hours you use. Generally speaking, users that use their workspace less than 80 hours should be on an hourly model, and users that use more than 80 hours in a given month should be on a monthly model. Workspaces are simple to deploy. You can deploy them easily via the console by simply picking the specific bundle and picking the users that you'd like to deploy them to. They're also deployable using our CLI and our APIs. And they're scalable and performant. I would strongly suggest that you take a look at the link below at the Getting Started documentation. It'll tell you a lot more about workspaces. Now, let's talk a little bit about connecting to a workspace, because a lot of the security and stability of workspaces is outlined in this diagram. Now, when you first connect to a workspace, you open your Workspaces client and you enter your credentials. This instantiates a SSL connection using TLS encryption to our authentication gateway and facilitates the initial handshake. Once all of the security and posture is met, including any additional factors that you set up, be they multi-factor authentication, an IP-based whitelist, certificate authentication, or restrictions on an individual client type. Once all of that is done, then the streaming gateway instantiates a second connection, denoted by line number 7. That starts a PCOIP or a WSP stream directly to your instance. Now, in the case of Linux workspaces, I do want to mention that we will strictly be using PCOIP. Workspaces and the gateways themselves all reside in managed VPCs, as shown in the top of the right-hand diagram. Once you get through the gateways, the instances themselves, denoted in the bottom right, are also sitting in a managed VPC. They have a network interface in that managed VPC, as well as the instance itself, that is all managed as part of the service. That network interface is utilized for communications with the streaming gateway and for the general management activities of the service. All traffic and ports that'll go through that are denoted in the admin guide. The workspaces also have a second interface. This will be F1 in the Amazon Linux context. This interface sits in your VPC. This is the interface where you denote what traffic can and cannot get from the workspace and where it can and cannot get from. This is internet access and access to your on-premises resources. So this split methodology allows you optionality, like allowing your users to connect from virtually anywhere while restricting their access once they get inside the workspace. So you can use this as a highly secure way to access your on-premises resources and ensure that your users are accessing the internet through your secure proxy, through your firewalls, or not at all, depending on your particular settings. Access to your on-premises resources will be facilitated in the same manner as you would with something like an EC2 instance via a direct connect or VPN. I do want to talk a little bit about Workspaces VPC design best practices. Now, Workspaces, both in their Linux and Windows variants, are end-user facing devices. So it's generally good practice to separate them from your shared services and from your infrastructure. Doing so allows you the strongest position to control traffic between them. It's always easier to tear down or modify existing walls in an internet sense versus build additional ones after the fact. So putting them in their own VPC gives you the most flexibility. Another thing I want to point out is that Workspaces leverage 2 availability zones when they're deploying. You'll set these up when you're setting up your directory connector, your simple AD instance, or your managed Active Directory instance. Workspaces will then round robin between these 2 subnets and will be deployed into the organizational unit that you denote. Also, they will inherit a security group specific to the AWS directory that you have deployed them with. One final thing that I do want to mention is that it's important to remember these are end-user facing devices. You should plan for growth, and you should remember to plan for security. So things like ensuring that the subnets are private and ensuring that you have enough IP space to grow your current footprint will really pay off down the road. So now that we've established a little bit about what workspaces are, let's talk about Amazon Linux workspaces. Amazon Linux workspaces leverage Amazon Linux 2, which is an LTS distribution. They're domain joined, so they leverage the same identity as your Windows instances. They leverage the Mate desktop environment, which is based on GNOME 2, and is a great desktop environment for systems with small or no GPU, as is the case with virtual desktops. Now, because they're an LTS distribution, we also include what we call Amazon Linux Extras. Amazon Linux Extras allows you to install certain curated modern applications while still having the benefits of an LTS distribution. One thing I do want to mention is that Amazon Linux 2 LTS will maintain LTS support through June 30th of 2023. Now, if you're familiar with Windows workspaces, you'll remember that they leverage two volumes, a C and a D drive, and that OS information resides on your C drive and profile of data resides on your D drive. This is the same with Linux workspaces, with the root volume sitting on one volume and the home directory on a separate volume. This allows us to individually snapshot both volumes and allows you to dynamically restore individual instances or move them to new bundles or different operations like that, depending on your needs. So if a machine has a problem, if it is kernel panicking because of some changes, or you really just want to blow it away, but you don't want to get rid of all of your profile data, you have that optionality. Again, I mentioned that there's two interfaces, but I do want to point that out once more. F0 is the managed network interface. This is sitting in the managed VPC and facilitates management traffic as well as streaming traffic. There is no route to the internet or anything else from that. It is virtually opaque to the individual user. All of the interesting stuff happens on F1, which is the interface in your VPC. This is how users access any of your on-prem resources, any of your resources in your AWS cloud, and if you allow them, the internet. So now that we've talked about what Amazon Linux workspaces are, let's talk a little bit about how you would manage them and the implications of setting one up. First, let's talk about the initial preparation. The first thing you should do anytime you set up a new instance, be it Linux or otherwise, is make sure it's up to date. This is especially true if this is going to be the base of your large deployment, in terms of a golden image, but equally important if this is going to be your individual system and your home for a while. Amazon Linux 2 is based on Enterprise Linux 7. So it leverages RPM packages and yum. So the first thing you should always do is run sudo yum upgrade. This will ensure that all of your packages are updated and that you're pulling from the latest sources. Now, many admins want to make sure that they have the EPEL repository enabled. This is extra packages for Enterprise Linux and contains a lot of common applications that businesses and Enterprise Linux users use. Because this is a common application and we want to make sure it's as easy as possible for you to install, we've included it in the Amazon Linux Extras package. So all you need to do to enable EPEL is type sudo Amazon Linux Extras install EPEL. And then finally, one of the things that you'll want to do on your base image or your individual workspace is make sure that the TerraDC file is properly modified. We'll go into this a little bit more, but I do want to point out that the TerraDC file is the equivalent to the group policy template in the Windows Workspaces world. It controls things like copy-paste behavior and the protocol encryption and things of that nature. We'll get into that in a moment. The important things that I want to mention here is that there is a lot of documentation in the man file. To get the documentation, you'll type man Pcolp-agent.conf, and to edit the file, you'll edit it using an escalated profile. So you'll use sudo, the editor of your choice, in my case, vi, /etc Pcolp-agent /Pcolp-agent.conf. Now, as I mentioned before, we offer Amazon Linux Extras. The link below will tell you a lot more about Amazon Linux Extras and the packages that are available. Amazon Linux Extras will allow you to make sure that you have up-to-date packages while maintaining a secure LTS distribution. Just to show you that this is a real Linux box and that you have the option to customize and make it the way you want, here's one of my boxes. As you can see, I've installed a different terminal, I've enabled terminal transparency, and I've enabled several packages from Amazon Linux Extras, including LibreOffice, GIMP, Docker, and the EPEL repository. Now, moving to security, I want to talk about 3 areas that are very important. I mentioned the Pcolp-agent.conf before. It's located in /etc PCOIP agent. Like the ADM template with Windows Workspaces, it modifies things like encryption level and copy paste, allowing you to determine if you want your users to copy and paste to and from the local system. You can enable this in either direction or not at all. So your users can copy into your workspace, out of your workspace, or not in either direction, based on the settings here. Another important thing to note is that this is also where you set your desktop environment. As mentioned, Amazon Linux Workspaces ship with a Mate desktop environment. This is a desktop environment that we have highly tuned for the best possible experience on the Amazon Linux Workspaces. But if there's another desktop environment that you prefer, this is where you'll set it. Also, we leverage the sudoers configuration. This allows you to maintain and control wheel access and is edited using vi sudo. By default, when you deploy a Linux workspace, the admin settings on the directory are honored. If you have administrative access enabled on the directory, the assigned user will be a member of the sudoers group. If you do not, then only domain admins will have access to sudo. If you enable it, then both will have access. Very important to remember this so that you tightly control who can and cannot escalate their rights on the machine. Finally, we also leverage the access.conf. This controls who can SSH to your machine. By default, only the assigned user and members of the domain administrators group in your Active Directory can SSH into the machine. One thing to note here, though, is that when workspaces are deployed, they inherit the workspaces members security group assigned to that directory. If you do not enable inbound SSH access in that security group, no one will be able to SSH into the instance. Much like their Windows counterparts, Amazon Linux workspaces leverage custom bundles. Custom bundles are key to large-scale deployments and to ensuring that your users have the correct base state. A workspaces bundle is an OS image, which includes any customizations you make, as well as a hardware type. You can learn more about them at the link below. When creating a workspace, you should make sure that you're following imaging best practices. So set up your workspace first, make sure that you install the security and application settings that you want, get it to right where you want, and then use the image capture option. This will create a new image in your image collection. You can then match this to a hardware type and create your own custom bundle. When deploying workspaces to users going forward, you can assign them that custom bundle, and that will immediately infer the hardware type and the OS and the customizations that they will receive. Workspaces on the Linux side are available in 6 different bundle types: Value, Standard, Performance, Power, and Power Pro, as outlined below. Again, check out the link and you can see all of the different bundles that you can deploy with Amazon Linux Workspaces. Finally, I want to talk about management at scale. Now, at the end of the day, Linux workspaces are Linux devices. You manage them at scale the same way you would manage traditional Linux instances at scale. One of the ways I like to maintain them is using AWS OpsWorks. OpsWorks allows you to deploy managed Puppet or Chef. In my case, I generally use Puppet. If you can see, there's a link below that that points to a blog post that shows you how to leverage OpsWorks with a bespoke Puppet module to control things like who's in the sudoers group, who has access.conf permissions, and what the specific settings in your Teradici conf are. This gives you a bit of an idea of how you would maintain hundreds or thousands of instances and ensure that at any time, the specific settings that you want are configured on those instances. In this blog case, we used Puppet, but you can certainly use things like Chef or Ansible or Salt or any other orchestration framework that you are familiar with. Finally, I want to say thank you very much for listening today. Again, I've been Justin Stokes, and I hope you have a great day.